This is a presentation on central tendencies. What I've started out by doing is if I have a data set up here, the first thing I'm going to do is put them in order. So always take that step. I have them in order. I'm going to be going through and finding the mean, median, mode, spread, the MAD, and the interquartile range, as well as doing a box and whiskers with them. So to find mean, I simply add the numbers and divide by the number of numbers. So I would add 2, 5, 7, 14, 20, 20, 28, 35, and 58. Then I'd count them, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So when I add them, I get 189. And then I take that 189 and I divide it by 9, the number of numbers, and that gets me a mean, or an average, of 21. To find the median stands for the middle number. So I'm looking to find the middle. First of all, they have to be in order, then I'm counting in to find the middle. So I tend to count in a couple. Well, I'm going to count in 3 and then 3. I'm not to the middle yet, so I count in another 1, and right there in the middle is 20. That is my median. If I happen to find 2 in the middle, I would add them and divide by 2, basically finding the mean of the 2 that are in the middle. Mode. Mode stands for what happens the most. So if I look at this, everything happens once here except for I have 2 20s. That means that is my mode. It's possible you don't have a mode if everything ties for first or for last. And it also is possible that you have more than one mode. If I would say have another 7, then I would have 7 as a mode and 20 as a mode. Spread is the distance between the high and the low. In other words, how spread out these numbers are. They go all the way from 2 to 58. So I take 58, the high, minus 2, the low, and oops, I guess that goes over here, and the spread is 56. MAD is the one that doesn't make sense to a lot of people, so let's talk about what it stands for. It stands for mean absolute deviation. Mean, so that means we're going to be finding average at some point. What are we finding average of? Absolute, like absolute value, only dealing with the positives. Deviation. Deviation means how far from center is it? How far is it deviating? So the center that we're going to be using for this is the mean. We have found the mean to be 21. So I'm going to take that 21 and basically plug in every number and subtract to find out how far it is. So I'm going to subtract 2 and find out how far away is 2 from 21. I get 19. So 2 is 19 from 21. I can continue and I would just substitute in a 5, and I would take 21 minus 5, get 16. 21 minus 7, get 14. Take 21 minus 14, get 7. Take 21 minus 20, get 1. 21 minus 20, get 1. 21 minus 28, I would get negative 7 if I did that problem, but I'm going to write it as a positive 7 because we're doing the absolute deviations, not deviations of positive or negative, just positive. So then I take 21 minus 35, which is 14 away, and then I take 21 minus 58, which is 37 away. Now I have their absolute deviations, so I need to add those together. I take 37 plus 14 plus 7 plus 1 plus 1 plus 7 plus 14 plus 16 plus 19, which gets me a total of 116. Now, that's the total of the deviations. Once again, we want the mean deviation, so I divide that by the number of numbers. Once again, I had 9 numbers, so I'm going to take that 116 and divide it by 9. Our answer is 12.8888, or 12.8 repeating, and that is our MAD. On average, we are 12.8 away from the mean. That's our MAD. To do interquartile range, I first of all need to be able to make a box and whiskers. So we're going to start with that box and whiskers understanding. Remember, a box and whiskers is basically dividing our information up into quartiles or fourths. So I'm going to take my information and plot it. We should be over a number line. I need to cover 0 to 60 basically. So 0, 60, right in the middle would be 30. It'd be 15. Be 45, so just a rough estimate of where these are. So I plot the low and the high. My lowest number is at 2, which would be somewhere in here. My highest number is at 58, which would be somewhere up here. The median I already found to be 20. So I'm going to plot my median at 20. Also, when I cut it at 20, I cut it into two halves. This lower half down here, and this upper half up here. So if I want to go to quarters or fourths, I need to cut a half in half. Think about it. If you take anything like a pizza, cut it in half, and then cut those halves in halves, you've cut it into fourths. And so I'm going to find the median of this lower half. So once again, I'm going to look and say, well, if I counted in from the sides, I'd end up with 5 and 7 in the middle. If I have 2 in the middle, I add and divide by 2. So that end up being 6. I'll plot that at 6, somewhere about in there. Then I do the exact same thing up top on the upper end, 20 and 58. I add them and divide by 2, which would then be 31.5, which will be right about in there. Connect those, you're going to have your box and your whiskers. Basically what you have is 25% of your data lies in each one of these sections. 25% here, 25% here, 25% here, and 25% here. The two pieces here that we're going to look specifically at are the upper quartile and the lower quartile. When we talk about the interquartile range, we're saying what is the range of the box, or how spread out is this box. We found that upper quartile to be 31.5. Found the lower quartile to be 6. So if I want the interquartile range, I find out the distance in between those, which is, of course, 25.5. And that is our interquartile range.